so make sure that you're not making noise with your rulers. Okay, so on the back side of this, I'm flipping over right now my graph paper. And on the back side, I'm going to write, this is section 7.5. This is called Graphing Systems of Inequalities. So far in this chapter, we've done graphing systems of equations, which means seeing where they cross. We've done substitution, we've done elimination. And this is the last section is going to be graphing systems of inequalities. Now, if two lines cross in a point, you guys agree? Two lines, they cross at a point. Where did two inequalities cross? Remember, inequalities look like this over here, the shaded stuff. Above or below the line, but we're not just thinking about one line anymore. We're thinking of, it could be anywhere. There actually is a situation called infinite solutions where there would be anywhere, yeah?
Between two different zones.
Right, so, okay, watch rulers, okay? So imagine that you've got rulers like this, or lines like this, and my purple ruler, we're shading above the line, so we're shading this way. Can you visualize it?
Yeah.
And my green ruler, we're shading above the line this way. So where are they both shaded? Where does it overlap? That V kind of at the top, this part, right there. Everybody agree?
Yeah.
Okay, so up here, the overlap would be, don't have enough hands, that spot right here. That's what we're going to be doing today. So we're graphing multiple lines at once and then seeing where they overlap, which will be a zone, like you said, instead of like a point. Everybody get it? Okay. All right, we're only going to do 3 examples, and one of them will be worth prizes, so here we go. Example 1, let's start with y. Again, I'm still on the back side here. Y is greater than 1/3 x plus 2, and x is greater than or equal to -3. Now, the first one looks like something I can graph right away. Hopefully you remember how to graph with this right here. What's the y-intercept of the first one?
1, 2.
2, right? And then what are we going to do from 2? Up 1 over 3. Everybody getting this? It's going to be a dotted or a solid line? It'll be a dotted because there's no equal sign, and we're going to shade above or below? Above, greater than, means above. But what does this line look like?
There's a straight line.
It is just a straight line, but is it a horizontal line or is it a vertical line? It's a vertical line. So why don't we write that next to this one right here? This one's going to be a vertical line. And maybe I'm going to write in the top corner of my notes here, if I see like y is less than a number, specifically just y and just a number, that one is going to be a horizontal line. Just so I can remember for myself that that would be horizontal. All right, I'm going to flip it over. We're going to graph example 1. So right now, using your ruler, draw in some axes. Okay. So I believe the line had an intercept of 2, correct?
Yeah.
So I'm going to start at 2. And then what was that slope? Up 1 to the right 3, up 1 to the right 3. I'm going to go the other way a little bit too. And this was just a greater than symbol, so greater than, does that mean that it's a solid line or a dotted line?
Dotted.
Dotted, okay. Here, this is a dotted line. Like that. And I'm not going to do any coloring yet, but I want it to be greater than that line. So where am I going to go?
Oh.
Up. Everybody understand it's kind of like up and to the left? Can everybody see the greater than?
Yep.
Beautiful. What I want you to do right now is I want you to draw some little arrows on your line that show we would be shading up here. But we're not going to shade yet because we don't know the final answer. The other one is x is greater than or equal to -3. We decided that was a vertical line. Where should my vertical line be? At -3. Do I go on my y or my x to -3? X, so I'm going to go to x at -3. Solid line or dotted? Solid, because it's greater than or equal to, right? Problems like this, it's really important that you label your x and your y, so make sure that you have labeled your x and your y, because we've got one that's going vertical right next to it, which means that it could be easily misinterpreted. Where's greater than -3? Is it on the left or on the right? It's on the, what numbers are bigger than -3? -2, 0, 5, these are numbers that are all over here. 126.2 is also over here. Great point. Pi is over there. Oh my gosh. You want to hear what monsters I have made from my children? I mean, we all knew that my children were going to be weird, right? Can we all agree? We all knew they're going to be weird. Mr. Baringa in 4th grade yesterday asked for a number between 1 and 10. And Penny says pi. And he was like, that's very cute, but that's not going to help me. I need I need a number that ends. So she says, how about 3.1492? And he's like, how about 3? And she's like, okay. But I thought that was very funny. She's like, isn't that cool, Mom? And I'm like, kind of really obnoxious. But you know, we'll work on it. Okay, where am I going to shade now? All right, here are your choices. Everybody look up, look up, look up. Make your eyes go up. There it is. All right. Option 1, 2, 3, 4.
So,
2. Do you see how the arrows are going up here and to the right there? We want where the arrows are pointing in on both. The only answer to this problem, this is where I want you to use your marker. The only answer to this problem is this kind of like zone over here. Notice that I'm not just coloring in the quadrant, my lines, these 2 lines, not the axes, but my lines are the ones that are the boundaries. How are we feeling about this stuff?
great.
Great, easy peasy. Example 2. Remember, we're only doing 3 examples today. All right. Example 2.